Both same. Okay. Yes. Introduction also both sides. So, good evening, everyone. Myself, Rekha. I have 14 years of experience in teaching high school kids like 8th, 9th, and physics and chemistry. And I have done my master's in maths, physics, as well as in BA physics. And I'm here to teach you class 10, one of the topic called as electricity. And thanks for Tutors Pride for giving me this opportunity. For giving me this opportunity. So let's start our topic called as electricity, which is 10th class, one of the most chapter in 10th class. See, as you know, electricity is very important in our lives. Like from morning to evening, everything we are dependent on electricity. So thanks to Benjamin Franklin, who discovered electricity in the year 1750, we can't assume our lives without electricity. Like, can we? Shall I use this? So we can't assume our lives without electricity. So thanks to Benjamin Franklin, who discovered electricity in the year 1752. Okay, so I'll tell you what is electricity. What is electricity? Electricity is nothing but it's a form of energy. It's a form of energy, and we can energy which involves the flow of electrons, which involves the flow of electrons, or else we can say electricity is made up of matter. It is made up of a matter. Again, matter exists in three forms, that is solids, liquids, and gases. Again, the question arises, what is matter? Matter is again made up of atoms. Atoms are nothing but they are the tiniest particle which are made up of subparticles called as electron, proton, and neutron. Electrons are negatively charged, protons are positively charged, and neutrons are neutral in charge. Okay, so this is about on whole about what is electricity. So electricity is nothing but it's a form of energy which involves in flow of electrons, we can define electricity is made up of a matter. Matter again it consists of, it is made up of exist in three forms, solids, liquids, and gases. Again, the matter is nothing but it is made up of atoms. Atoms again it's the tiniest particle which is made up of subparticles called as electrons, protons, and neutrons. Electrons are negatively charged particle and protons are positively charged particle, and neutrons are neutrally charged. And then we'll go for like this is about electricity, and we are going to discuss some topics in electricity. See, in electricity there are many topics, but today I'm going to discuss about electric current and potential difference, and the thirdly Ohm's law. Ohm's law. So earlier I told that in electricity we have many topics, but today I'm going to tell you about few topics called as electric current, potential difference, and Ohm's law. Let's see what is electric current. So electric current is nothing but uh, it's a flow of electrons, we can say, or else I'll tell you with an example. Like assume an conductor. Okay, in this conductor some electrons, and I'll point it as A and B, and this is the direction in which the electrons flow. and this is the direction in which flow of current, flow of, and this flow of electrons. Always you remember that it's a conductor. The conductor consists of few electrons in this, and if at all the electrons, if electrons move in this way, the flow of electrons will be always opposite to the direction of flow of electrons. So that is the reason current is called as convection current. I'll tell you what is the reason why this opposite directions goes on, because whatever the electrons are passing in the conductor, they are considered to be negatively charged particle, and whatever the charge is being supplied in the circuit, that is considered to be positively charged. So always the negative and positively charged particles will always travel in opposite direction. So that is called as a electric current. So here electric current is denoted by I. I is equals to, we will call it as Q by T. We'll call it as Q by T. Q is nothing but, it's a charge. And T is nothing but, it's a time. And I is nothing but, it's a current. So by seeing this formula itself, we can define what is electric current. What is electric current? So the definition of electric current is nothing but the rate of charge per unit time is called as a current. What is the definition of electric current? Electric current is nothing but the rate of charge per unit time is called as a current. Here I is equals to Q by T. Now we'll go for the SI unit. SI unit of current. So by seeing this formula, we can write what is the SI unit of current. Q is charge. Unit of charge is coulombs and unit of time is seconds. So I is equals to coulombs per seconds is nothing but 1 ampere. It's nothing but 1 ampere. Unit of current, SI unit of current is nothing but 1 ampere. Once again, I'll explain you what is electric current. Electric current is nothing but it's a rate of flow of charge per unit time is called as a electric current, and formula is I is equals to Q by T. I is nothing but it's a current, and Q is the charge, and T is the time. By seeing this formula itself, we can write the SI unit of current. SI unit of charge is coulombs, unit of time is seconds. That is I seconds. Coulombs per seconds is nothing but it's equal to 1 ampere. If anybody will ask you what is SI unit, then you can say ampere. Ampere. SI unit of electric current is ampere. So what we have discussed in electric current, I have given the definition. I'll tell you we have discussed. Okay. I have given the definition. Firstly, and secondly, I have given the SI unit. Thirdly, I have given the formula. Definition, SI unit and formula. So that is what it's called as a definition is the rate of flow of charge per unit time is called as a current, and SI unit is nothing but ampere, and formula is I is equals to Q by T. And now there may be a question arise for 1 mark, like what is the device used to measure electric current? So the device used to measure the electric current is nothing but it's a ammeter. Ammeter is the device used to measure electric current. It's a device used to measure the electric current is nothing but it's a ammeter, or we can say ampere. The device used to measure the ampere is nothing but ammeter. Okay, this was about electric current. So the second topic is potential difference. So before going to potential difference, I'll tell you about free electrons, and you'll come to know why I have explained about free electrons. What are these free electrons? For example, to understand these free electrons, I have to give you one example of any metal. For example, of copper, I'll give. So what is the copper atomic number is 29. And let's write the electronic configuration of copper. So electronic configuration of copper is nothing but 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. 4s1, 3d10. This is the electronic configuration of copper. In short, we can write as organ 4s1, 3d10 configuration of copper. So here, I'll explain you what is this is the nucleus. Atomic orbital of copper. So here 2, 8, 18, and there's the free electron. Okay, just roughly I'm writing the electrons here, 2, 8, 18. So this is the free electron. This is the free electron of copper. What is the free electron? Is nothing but the electron which is easily available to jump from one atom to another atom. Those electrons are called as free electrons. And these free electrons are mostly present in conductors. That is the reason that most of the electrical wires are made up of metals. Why? Because metals are good conductors of electricity. Now you may get doubt, what are these conductors? I'll tell you what are these conductors. Conductors are nothing but, I'll tell you conductors and semiconductors and insulators. So these are the three things we have to know. What are these? Conductors, semiconductors, and insulators. All metals and electrolytes comes under conductors, and wood comes under insulators. In semiconductors, we can say germanium and silicon. So conductors are nothing but, as we have discussed earlier, free electrons. I think you might have understand why I have explained about free electrons now. Free electrons means conductors have they possess high number of free electrons to conduct electricity. Whereas insulators have low free electrons. They don't have any free electrons. Whereas in semiconductors, sometimes they have high number of electrons and sometimes low number of electrons. Okay, conductors are good conductors of electricity, bad conductors of electricity. They behave sometimes good as well as bad conductors of electricity. So I'll tell you what are the conductors. Conductors consist of high number of free electrons. So it allows the electricity easily. So they are called as conductors. And semiconductors, they behave intermediate, like they behave the conductivity of both conductors as well as insulators. So they are called as semiconductors. Whereas insulators doesn't exist in free electrons. No free electrons are present in insulators. Means it will not allow the flow of electricity. So they are called as insulators. Seen what are the which metal is used to make the electrical wires? So the answer is copper. Electrical wires are mostly made up of copper because it allows the electricity fastly. And you might have seen to the electrical wires, we use some insulations like plastic insulation. Because why? Plastics are bad conductors of electricity. So these are the few of the examples of conductors, semiconductors and insulators. So let's go for the next topic, potential difference. Potential difference. So before going to this potential difference, I'll ask you a few questions like point A, point B, high temperature and low temperature. And example 1, example 2, point A, point B, high level and low level. Like here I'll ask you the flow of heat and flow of water. Here I'll ask flow of heat. Does the flow of heat occurs from high temperature to low temperature or low temperature to high temperature? And the same question arises here. Does the flow of water occurs from high level to low level or low level to high level? So here, definitely, whether it is a flow of heat, flow of energy, or a flow of water, it flows from high level to low level, high temperature to low temperature, high level to lower level, high potential to lower potential. That high to low is a sort of some difference. It's some sort of some difference, means here some amount of work, is done. Some amount of work is done. That is nothing but potential difference. Potential difference. I'll explain you with one more example what is potential difference is with a clear example. This is, I have given the examples of flow of heat and flow of water. Now let's see one more example. Potential difference is like point A, point B. Here I want to move 1 unit positive charge from A to B. Here I want to move this 1 unit positive charge from A to B. So to move this 1 unit of positive charge from A to B, here I have to apply some force. I should apply some force to A. Then only the charge from A will move to B. That is called as dist, and this is the force. So when I have applied some force, definitely some force need to be applied, then only the charge from A, like some amount of work is done, some charge of A will move to the B, means some sort of displacement is done here. And indirectly we can say, or directly we can say, some amount of work is done. Some amount of work is done to move this charge from point A to point B. Like W, what is W? Work done is equals to F into S. You might have studied. In 8th standard, you might have studied what is W. W is nothing but it's a work done. And F is nothing but force. And S is nothing but displacement. What is displacement? To move an object from one point to another, that is called as a displacement. Force is nothing but mass per unit area. Mass per unit area is called as a force. So W is equals to F into S. Here you might have seen that some amount of work is done to move this one positive charge from point A. On whole, it is called as a potential difference. This is called as a potential difference. I'll tell you in a formula way, like potential difference is denoted as V. V is equals to W by Q. Like V is nothing but V is equals to W by Q. What is W? W is nothing but some amount of work is done to move some charge. That is called as potential difference. I'll tell you what is the SI unit of potential difference. Potential work is nothing but joules per coulombs, which is equals to 1 volt. If anybody will ask you what is the SI unit of potential difference, you can say 1 volt. So once again, I'll tell you what is potential difference. Potential difference, by seeing this formula itself, you can write the statement or definition of a potential difference. Potential difference is nothing but the amount of work done to move a unit positive charge from one point is called as a potential difference. That is, V is equals to W by Q, and W is nothing but work done. What is the unit of work? Joules. Unit of charge? Coulombs. Joules per coulombs is nothing but it is 1 volt. So SI unit of potential difference is 1 volt. And there will be one more question. Which device is used to measure the potential difference? So that is nothing but voltmeter. So indirect question they may ask, which device is used to measure the volts? The device used to measure the volt is nothing but voltmeter, and the device used to measure the ampere is nothing but ammeter. So this is about, on whole, this is nothing but about potential difference. Potential difference is nothing but the amount of work done to move a unit positive charge from one point to another point is called as a potential difference. So what we have discussed in potential differences, I'll tell you. Firstly, we have discussed about definition, and secondly, I told you about the formulae, and thirdly, I told about SI unit, and fourth, device. And now I'll tell you one numerical, just a numerical for 2 marks or 1 mark questions you may get. For example, one small numerical I'll ask you, like point A possess of 50 volts and point B possess of 30 volts, and point A has 2 charges, coulombs, and what is the amount of work done? So which formula you are going to use to calculate the work done? Simple as it is, nothing. V is equals to Q. So what is the V? V is nothing but potential difference. So 50 minus 30. 50 minus 30, 20 watts. And W, we are supposed to find out. Q, it's already been given, 2 charges. So W is nothing but 20 into 2, which is called as 40 joules. Why joules? Because the unit of work is joules. Again, I'll explain you. If it is a given 2 points, like point A, 50 volts, point B consists of 30 volts, and a charge is given as 2 coulombs. And if they ask what is amount of work done over here, so which formula you are going to use? V is equals to W by Q. W is the work done, Q is the charge, V is the potential difference. So V is being given, which is the potential difference of 50 and 30. Always potential difference means 50 minus 30 is nothing but 20 volts, which I have given over here, and W is as it is, Q, which is given as 2. Just you have to put this 2, and then you'll be getting 40 joules. So what is the work done over here? Work done over here is 40 joules. So this is the numerical related to potential difference. Let's go for the next topic, that is Ohm's law. So before going to the Ohm's law, I'll give few examples. Like this is a conductor. I have induced some 10 volts plus on the either side 0, and here some electrons in this conductor. Let's say current as 1 ampere. Let's say, just assume. And then secondly, the same conductor, same material, everything. So the either side 0, some electrons. Say current as 2 amperes, and Thirdly, 30 volts, same conductor, everything, temperature remains constant, physical condition remains same, and the either side 0 volts. Say the current as 3 amperes, say. Okay, so from these three examples, what you people observe or what you people infer in these three examples. So I'll tell you what is the difference between these three examples. See, here the amount of potential difference is, so the current is 1 ampere, and here the potential difference is 20 volts, and here the current is 2 amperes, and here induced potential difference is 30 and the current is 3. So here it is 10, so it is 1A, I have doubled, so the current is been doubled. I have tripled over here, the current is been tripled over here. So by seeing this, we can directly say that V is directly proportional to I. V is directly proportional to I. What is V? Is nothing but it is the potential difference. It is the potential difference. And what is I over here? I is the current, right? So I'll show this in a graphical representation. Graphical representation I'll show you. Okay. So x-axis, y-axis, 1 ampere, 2 amperes, and 3 amperes. Here it is current, and this will be V, and this is 10 volts, 20 volts, and 30 volts. So I'll plot the graph between these three examples. That is the x-axis. On x-axis we have to take the current, and on y-axis we have to take volt. That is potential difference. So 10 volts. 10 volts is equal to what is the current? 1 ampere, right? And 20 volts. And 30. So you can see the graph. The graph will be, the plotted graph will be like this way, that is a straight line, and we can easily say by seeing the graph as well as this example that V is directly proportional to I. V is directly proportional to I. V is the potential difference, I is the current. So to remove this proportionality, we are supposed to introduce one proportionality constant, which is called as R. We are supposed to introduce one proportionality constant that is called as resistance and proportionality constant. Okay, then this is nothing but this is called as Ohm's law. This is nothing but this is called as Ohm's law. What is Ohm's law? V equals to IR. So hereby this examples in graphical representation, we can directly say that V is directly proportional to I. The amount of potential difference is induced potential difference is directly proportional to the induced amount of the current, that is V is directly proportional to I. So to remove this proportionality symbol, we are supposed to introduce a constant that is called as proportionality constant, which we are introducing R. R is nothing but resistance. Resistance. What is resistance here? What is resistance? So resistance is nothing but which opposes the flow of current. Which of current is called as a resistance. What is the unit of resistance? Unit of resistance is nothing but ohms, which is denoted as this. Okay, so this is all about Ohm's law. What is Ohm's law? V is equals to IR. And unit of resistance definition is resistance is nothing but which opposes the flow of current, and unit of resistance is ohms. And here one more thing we have to discuss. Here everything, here the temperature should be same, and all physical conditions should be same. All physical conditions should be same. What are those physical conditions? Like it may be pressure, it may be humidity, it may be force. These all physical conditions should be same over here. Then this applies, V is directly proportional to I. So here resistance equals to what is the R is nothing but it's a proportionality constant, which it is called as a resistance. This resistant does not depends on anything. It only depends on the conductor. Resistance depends on the conductor. Okay, once again I'll tell you this, then I'll go for this next topic, how resistance depends upon the conductor. So here Ohm's law, what I have done in Ohm's law, just I have given the three examples. Example, I have induced some 10 volts and in a conductor, on the either side it is 0 volts. So what is the current over here? It is 1 ampere. It's a 1 ampere. And in second example, I have given induced 20 volts and the either side 0. Then how much the current is being noticed over here? Say as 2 amperes. And thirdly, 30 volts, say the current as 3 amperes. So from these three examples, what we have observed in these three examples, the temperature will be same and all be same. So from three examples, we have observed that V is directly proportional to I. How can we say that V is directly proportional to I? Because here, as I have increased potential difference, the amount of current is being increased. Here I have doubled it. Then current is being doubled. I have tripled it. Then the current has been tripled over here. So that by seeing this, we can say that V is directly proportional to I. Potential difference is directly proportional to I. And here, by graphical representation also, I have shown V is directly proportional to I. So what I took on x-axis, I took current. On y-axis, potential difference. Okay, 10 volts, 1 ampere, 20 volts, 2 ampere as it is. 30 volts, 3 ampere. So this is the graphical representation of volts, potential difference and current. Okay, so by this graphical representation, V is directly proportional to I. To remove this proportionality constant, I have introduced one proportionality constant called as R. That is proportionality constant, which is also called as resistance. And resistance definition is nothing but which opposes the flow of current. Which opposes the flow of current is called as a resistance. And if anybody will ask you what is the unit of resistance, unit of resistance is nothing but ohms. And what is the unit of current? Unit of current is ampere. Just checking, unit of current is ampere. And unit of potential difference is volt, and unit of resistance is ohms. So here, as of now, what we have discussed, I'll again recall it. Then I'll go for the next topic. So till now, we have discussed about electric current, in electric current, what are the parameters we have discussed? Definition, formula, SI unit, and device, and free electrons, about conductors, insulators, and semiconductors in electric circuit. And in potential difference, we have discussed about definition, formulae, SI unit, and numerical. So in electric current, these are the topics we have discussed. Definition is nothing but rate of flow of charge per unit time is called electric current. And formula I equals to T. SI unit, ampere, or we can call as coulombs per second. And device is nothing but ammeter. Free electrons easily available in outermost shell. So these are discussed in electric current, definition, formula, SI unit, device, free electrons, conductors, insulators, and semiconductors. And then potential difference. What is potential difference is nothing but amount of work done in moving one unit positive charge is called as a potential difference. What is the formula to W by Q? Unit is volt, or we can call it as volt can be also written as joules per coulombs, and device is nothing but voltmeter. So as of now we have discussed this electric current potential difference, and thirdly we also discussed about Ohm's law. Ohm's V equals to IR. V equals to IR. Okay, V is the potential difference, I is the current, and R is the resistance, which is constant always. Now, as I told you, why R is depends on conductor and how R depends upon the conductor. Resistance depends on the conductor. Let's see how resistance depends upon the conductor. As I've discussed, it's nothing but which opposes resistance is nothing but which opposes the flow of current is called as resistance, and units of resistance is ohms, which is symbol, this is the ohm symbol. And let's see, resistance depends upon two parameters, that is one, length, and area of cross section. Let's see how does the resistance depends upon the two parameters, length and area of cross section. For example, here long and short, thick and thin. So here I have given 4 examples. I have shown some samples over here. This is the same material or the same conductor, but their sizes are and their area of cross section is different. You can see A, it's a longer wire, shorter wire, thick, thin. So here what you will see is this is the length, this is the length, area of the cross section, area of the cross section. So here you'll find more resistance and here less resistance. Why in longer wire the resistance is more? You may get this doubt because in longer wire electrons will travel, they have more space in longer wires. So what happens when they travel the longer length? There may be those electrons will collide with the ions present in the metal. So when the electrons collide with the ions present in the metal, what happens? It opposes the flow of the current. It opposes the flow of current is nothing but it has resistance. The same happens over here in shorter length, that is it has less resistance. So by this we can directly say that resistance is proportional to length. The more resistance, the more length, the more resistance. Okay, R is directly proportional to length. More length, more resistance, shorter length, less resistance. And when it comes to the area of cross section, here you can see thick wire and thin wire. So in thick wire, electrons will get more space to travel. Right? More space to travel, it cannot carry the same energy of the electrons. Energy cannot be traveled with the same energy. So what happens over here? Here, it consists of more resistance and here less resistance. Okay, more resistance and less resistance. So in area of cross section, if it is thin, the resistance will be more. If it is thick, the resistance will be less. I have told you the reason, because if it is a more space to travel and it cannot travel with the same energy till end. So here by this we can say R is inversely proportional to one area of cross section. So from 1 and 2 we can say R is proportional to L and inversely proportional to area of cross section. So from 1 and 2 we can write R is proportional to length and inversely proportional to area of cross section A. Again, to proportionality constant, I have to introduce one more proportionality constant called as rho, which is called as rho, or it is also called as resistivity. It is also called as resistivity. Resistivity is nothing but property of the particular material. Property of material. Okay. Again, I'll repeat this. It is nothing but 4 examples I have given. In first example, the length of the wire is longer, and in B, the length of the wire is shorter, and C, the thickness of the wire is more, and in D, the thickness is thin wire. So you can see here in longer wire the resistance is more, and in the shorter wire the resistance is less. So from these 2 examples, it is directly we can say R is directly proportional to length. And from this last 2 examples, C and D, we can say the R is inversely proportional to the area of cross section. So from 1 and 2 is proportional to L, and R is inversely proportional to 1 by A. That is area of cross section. Okay, and R is directly proportional to length and area. To remove this proportionality, we have to introduce one proportionality constant, which is called as rho. Rho is nothing but it is resistivity. Resistivity is nothing but property of the material. So on whole, it is nothing but it gives the relationship between resistance and resistivity. Resistance opposes the flow of current, and unit of resistance is ohms. And again, the resistance depends upon the 2 parameters, that is length Length means resistance is directly proportional to length and inversely proportional to area of cross section. That is, R is directly proportional to L, inversely proportional to 1 by A. On whole, R is equals to rho L by A. And here, this R is the resistivity. So this is all Ohm's law. So Ohm's law is nothing but V is equals to IR. And one more interesting thing is V is equals to IR. I can draw. This is Ohm's law. And based upon this Ohm's law, again there are two conductors. That is nothing but ohmic conductors. These things are in later come to know what are ohmic conductors and non-ohmic conductors. Ohmic conductors which obeys Ohm's law, ohmic conductors, and which does not obey Ohm's law, they are called as non-ohmic conductors. That's all about the topics given today for electricity. So here till now we have discussed about electric current, potential difference, Ohm's law, and the relationship between resistance and resistivity. So as I told you, based on Ohm's law, there are two conductors which are called as ohmic conductors and conductors. So ohmic conductors which obeys Ohm's law is called as ohmic conductors. That is V equals to IR. And non-ohmic conductors which does not obey Ohm's law is called non-ohmic conductors. Okay, this is all about today's topic, electric current, electricity. So in electricity, we have discussed lot many today. That is electric current. In electric current, we have discussed about the definition, symbol, formulae, and device. Same as in semiconductors, conductors, and insulators. And whereas in potential difference also, we have discussed many things like definition, device, SI unit, and numerical also. And whereas potential difference, I have shown few of the numericals. And discussed, and in Ohm's law I have shown the graphical representation and I have given the three examples which shows that V is directly proportional to I, that is V is equals to IR. And I have shown about the relationship between the resistance and the resistivity. Resistance and resistivity is nothing but, if anybody will ask you what is the relation between resistance and resistivity, you can easily show them with the formula R equals to rho L by A. This is the relationship between resistance and resistivity. Rho is the resistivity, L is the length, A is the area of cross section, and R is equals to resistance. So I'll give you the again some revision type what we have discussed in Ohm's law. In Ohm's law, we have discussed about definition, formula, and graph, examples, ohmic conductors, and non-ohmic conductors, and resistance depends upon the conductor. Resistance depends upon the conductor and on what parameters, on what factors does depends. So it depends on length and area of cross section. So in Ohm's law, what we have discussed, we have discussed about the definition and we have discussed about the formula V equals to IR. Okay, and graph and examples, and what are ohmic conductors, what are non-ohmic conductors. Ohmic conductors are nothing. Ohm's law are called as ohmic conductors, and non-ohmic conductors which does not obey the Ohm's law. Which does not obey the Ohm's law means V equals to IR. Which does not obey the Ohm's law is the non-ohmic conductor, and which obeys the Ohm's law is the ohmic conductor. And then we have discussed about resistance. What is resistance? And resistance, the name itself, in the name itself it is as resist, opposes, which opposes the flow of current is called as resistance. And also we have discussed about units, that is ohms, which is denoted by the symbol ohms, right? So resistance depends upon the conductor and on what factors does the resistance depends. So resistance depends upon the length and it also depends upon the area of the cross section. Length means R proportional to L and R is inversely proportional to 1 by A. This is the relation between resistance and length and area of cross section. When it comes to length, it is directly proportional to the length. More the length, more resistance, less length, less resistance. And if it is area of cross section, like if it is thicker, then the resistance will be less, and if it is thinner, the resistance will be more. So we can say it is inversely proportional to the area of cross section, that is R is inverse 1 by A. So on whole, from 1 and 2, we can say R proportional to L by A. To remove this, I have introduced. So this is the relationship between resistance and resistivity. Resistivity is denoted. Resistivity is denoted as rho. We'll call it as rho, property of the material. Property of the material. So that's it for today. Thank you. And if you please like my video, please do subscribe. Thanks a lot.